everybody and welcome back to the ELLYACADEMY's channel. Today we will talk about containers, Docker. In the last video I talked about Kubernetes and how it abstracts the infrastructure and orchestrate a lot of containers, but today we will focus and understand more about the container itself. In order to understand that, it's a good idea if you compare with the solution that we used before to provide the isolation that our applications need. So let's compare the use of containers with the use of virtual machines. Well, what is the difference? What makes a container a better choice for us or not? Let's imagine that you have here your server, a bare metal, running in your infrastructure. Let's say that is the server 1, and you want to provide isolation for your applications through the use of virtual machines. What will probably happen is that your server will be running an operational system, some version of the Linux, and in order to provide the virtual machines, it will be running also an hypervisor. And then you can run maybe 1, 2, 3 virtual machines with your applications running on those virtual machines. Let's say that you have here one simple application, here another, a bigger one, and here another application. All those applications will be running with the isolation that you want. But what's happened with virtual machines is this is not a cheap process, because the virtual machine has its own OS running, his own operational system running. Let's say it's a gas operational system here and here. Well, that will impact to the way that your application access the CPU of this bare metal machine, because your application will be requesting processes to a virtual CPU running to each of those virtual machines. And what is happened when you use containers is that you don't have that extra layer of communication. Another problem that you have by using virtual machines is that, well, they are not cheap, so you have to maybe deploy more than one application in the same virtual machine, because you don't have all the resources to create another server to run another virtual machine. But with containers you have a cheaper way to run your applications in with the isolation that you need. So let's say that you are running your application now using containers. That way you have only one operational system and you will be running a lot of containers on that machine. So I'm here drawing a lot of containers, more than I expected. Okay, and each container will access the operational system and will access the CPU without any kind of virtualizations, and that brings a lot of performance to the process, because you don't have to start a whole operational system. So then you can start your application. Your application can start already in the operational system of the server. If we focus on the model of the communication between your application and the CPU of the server, you see the difference between the virtual machine and the container being something like that. Let's say that you have a virtual machine here. I will delete this and I will start again. Okay, so we have one machine running with virtual machines here. Let's say you have your virtual machine here. So VM1 and another virtual machine here, VM2, and you have your application here. Let's say you have two applications here and two applications here. So each virtual machine has his own kernel Linux. And that kernel, let's say that you know that here I wrote kernel, okay, and that kernel have to access not the CPU but a virtual, let's say virtual CPU here and a virtual CPU here too, over an hypervisor, and then the physical CPU, let's say physical CPU of the node where it is running. If you are using containers, so here is using VMs and here is using containers. Well, the difference is that you have your physical CPU here. So physical CPU, you have your kernel here. Alright, and then you already have your containers. Let's say that you have one container. There will be a lot of containers, but I will not draw a lot of containers anymore. So 1, 2, 3, and that's good. And each container run your application, only one application for container, because the container is cheaper. You can create much more containers in the semi-bare method. So let's create another application here. Well, in the container you communicate with the kernel, and the kernel with the physical CPU already. At this point you are probably wondering how a container works, how it provides isolation for my application. And the beauty of all this is that any container technology uses two resources of the kernel Linux to provide isolation for your application. It is Linux namespaces, what provide to your process a personal view of the system, limiting the access to files, processes, network interfaces, host name. And the second resource is the Linux control groups, which limits the amount of resources the process can consume, like CPU, memory, network bandwidth, and so on. And all the container technologies use these two resources of the Linux, even Docker, and when you are running in other operational system like Mac OS or Windows, the difference is that it will run over a virtual machine. That is it for today, guys. I see you in the next video, and please don't forget to subscribe the channel. You'll be helping me a lot with the work that I'm doing here.